Hello everyone, I welcome you all in the online lecture series of Environmental Engineering 1. Our today's topic is water distribution system. In the last lecture we have seen the softening of water or the miscellaneous treatment methods of the treated water, or it was the last phase of the water treatment plant. So after the water is treated, it is necessarily distributed to the consumers. So today we are going to see the water distribution system. The contents of today's lecture are introduction, requirements of distribution system, systems of water supply, then classification of distribution systems, and the different layouts of distribution networks. Okay. So the distribution of water is the last phase of any water supply scheme. The function of the distribution system is to furnish the treated water in required quantity, maintaining its quality under required pressure wherever it is needed in the city or the town. The consumption of the water may be for residential, for industrial, it may be for the commercial or the public purpose, etc. So the main purpose of the distribution system is to deliver the water to consumer with appropriate quality, quantity and the pressure. So this is the main objective of the water distribution system. Basically this distribution system consists of the network pipes comprising of mains or large diameter pipes, then sub-mains, then branch pipes, and lastly the feeder pipes or the lateral pipes. Apart from the network pipes, the distribution system is having the valves for controlling the flow in the pipes, different types of valves, then fire hydrants, service connections, water meters, distribution reservoir or service reservoir, and the pumps. So combining all these things together, it is called as a water distribution system. Okay. So in the image or a photograph you can see the treated water is conveyed to the elevated storage reservoir, and from that ESR or elevated service reservoir it is then distributed among the consumers. Okay. Now we will see the requirements of a distribution system or the factors which are to be considered in the design of the distribution system. So following are the requirements of distribution system. First is it should satisfy all the types of demands including the fire demand of a town. Then it should provide water at the consumer's tap with adequate pressure head, and it should be capable to meet the maximum hourly flow. The water quality should not get deteriorated in the distribution pipes, and lastly it should maintain the degree of purity while conveying the treated water from the waterworks to the consumer. So these are some requirements of the distribution system. So our basic aim is to provide the pure water to the consumers without compromising the quality and the quantity of the treated water. So this is the basic aim behind every water supply scheme. Okay. Now again there are some other requirements. The pipes in the distribution network should be completely watertight to avoid the contamination of the water. The cost of the construction and maintenance should be minimum. The cost of distribution system is about 65 to 70% of the total cost of the water supply scheme. So please note that the 70% almost cost of the whole water supply scheme is because of the distribution system. So the other 30% is spent on the water treatment units. So it is very necessary to design the distribution system in such a manner that the consumer must get the water with the purity and quality of water. Now during the repairs there should not be any obstruction to the traffic, and all the distribution pipes should be preferably laid 1 meter away or above the sewer line. So this point is also very important, that the distribution pipes should be at least 1 meter away from the sewer line, so as not to get the water mixed if there is a leakage in any one of the line, whether it is a sewer line or it is a water line. Okay. Now we will see the systems of the water supply. So basically there are two systems of the water supply to the public. First is the continuous system, and second system is called as the intermittent system. So continuous system, in this system water is supplied throughout the day, that is 24 hours without any break. When the water is available for distribution is in abundance, this system is used. The system is ideal since the water is not remaining stagnant at any time in the pipeline, and the fresh water is always available to the public. So the continuous system means the water is supplied throughout the day at any time, so that the consumer should not or it is not necessary to store the water for the consumer level. It is available at any time of the day. Okay. So this is the continuous system. Intermittent system, in this system water is supplied to the public during some fixed hours of the day. Hence the supply is said to be intermittent. That generally water supply is 3 to 4 hours in the morning as well as in the evening. The system is required to be adopted when the sufficient quantity of water is not available, or when sufficient pressure cannot be maintained in the system. So under such circumstances various zones in the town are supplied with the water by rotation. So this system is most widely used in the India. So there are these two systems, continuous and intermittent system. At many places there is the intermittent system is there. Okay. So there are some comparison points between the continuous system and the intermittent system. So if in case of continuous system, consumers are not required to store the water and no danger of water pollution. Okay. So as there is a continuous flow of water, or the supply of water is for 24 hours, the consumer shall not need to store the water, and they are not storing the water, therefore there is no danger of the water pollution. In case of intermittent system, the consumers are forced to store the water for non-supply hours, which may get polluted if the necessary care is not taken. Then in case of continuous system, water is available for firefighting in case of fire break, because there is enough quantity of water is available. And in case of intermittent system, in case of fire during non-supply hours, water may not be available. So this is a very important point. Third point is, smaller size of pipes are needed for the distribution system as far as continuous system is concerned, and in case of intermittent system the large size of pipes are required as the daily demand is to be supplied in a small period. In case of continuous system, the water remains fresh because of the constant circulation of water, but in case of intermittent system it may get contaminated. The continuous system is the method, this method is convenient to all the consumers as the water is available at any time. The intermittent system is not suitable to all the consumers as they have to wait till the supply starts. Okay. Now we will move forward towards the classification of the distribution system. Now we have seen the systems of water supply to the public, that was continuous system and the intermittent system. Now if we go forward to the distribution system, the classification of distribution system is of three types: the pumping system, gravity system, and the combination of pumping and gravity system. Okay. So how the water supplies? It may be supplied either by using the pumping, or it may be supplied by the gravity flow, and either it is a combination of these two. So this is totally depend on the topography of the town or the area to which the water is to be supplied. So first system, now here in this slide we can see the three types of the distribution system. First type is the pumping system, that we can see in the diagram, that the treated water is directly pumped into the distribution mains without storing in high level reservoirs. So the water is not stored in the reservoirs, it is directly pumped into the distribution mains, and high lift pumps are provided for forcing the water into the mains. So here you can see the pumps are used, or high lift pumps are used for providing the water into the mains. Since the demand of water is fluctuating, which means it changes with the time, the pumps have to operate at various rates during the whole day. A continuous attendance is required at the pumping station to regulate the flow by running only the required number of pumps out of the total number of pumps installed. So there is more manpower is required in case of pumping system, and during the failure of pumps or electric supply, the water supply to the town may be interrupted. To avoid this, it is desirable to have some units of pumps running on the diesel. So some units of the pumps will be running on the diesel, some units of the pumps will be running on the electric supply, so as not to get the water supply of the town interrupted. Okay. So this is the first distribution system, that is the pumping system. Second is the gravity system. In this system, the gravity force is used in distributing the water from high level source to the low level zone consumer. Okay. So the water is supplied by the gravity flow. Again, the water is not stored into the any tank. So this eliminates the pumping together. This method is economical, reliable, and requires the less maintenance. For proper working of the system, the difference of head available between service reservoir and low level zone should be sufficient to develop enough pressure at the consumer's tap. The method also minimizes the wastage and the leakages. So this is the gravity system of water distribution supply. The third system is the combination of pumping and gravity system, which is also called as the dual system. So in this system, the water after treatment is pumped and stored in the elevated service reservoir. So according to the supply hours, the stored water is supplied to the public by gravity. So in the diagram you can see the pump house, elevated service reservoir is there, and hydraulic grades for minimum and peak demands. The system enables the pumps to operate at constant speeds at designed optimum efficiency, reducing wear and tear and overall cost. So the advantages of this combination of pumping and gravity system are: the system is economical, efficient and reliable and adopted practically everywhere. So pumping at constant rate increases the efficiency of the system, and special supervision is not required for this system. And another advantage of this system is the fire demand can be efficiently met with. The water is available even during the failure of pump or the power. So this was about the distribution systems of the pipes or the water distribution systems, types of water distribution system. Now the next topic is the layouts of the distribution pipe network. Okay, so now we have seen the distribution types of the distribution system. The distribution of water may be of the pumping system type, or it may be of a gravity system type, or it may be of a combination of the pumping and gravity system. Now the layout of the distribution types pipe network is: the distribution of pipe are always laid below the road prevailing in the town. So also they are laid on one side of the road, keeping the other side of the road for laying of sewers in the future. The layout of pipelines naturally follows the patterns of the roads. The following are the 4 types of systems. In the flowchart you can see there are 4 types of distribution networks. First is the tree or dead end system network. Number 2 is a ring or circular system network. Third is grid or interlaced system, and fourth is the radial system. Okay, so we'll go one by one. First is the tree or dead end system. The layout of pipelines resembles the nature of a tree, and hence the name is given as a tree system or the dead end system. There is one main pipeline from which number of submains are taken out according to the number of roads. From each submain, number of branch lines are taken out. From each branch, lateral feeder is taken out, and from where the service connections are given to the consumers. The branch lines are sometimes used for giving service connections. Water flows from main line to the subline and then to the branches. The water thus flows only in the one direction through all the pipes till it comes to the dead end. Okay, so there is only flow in the one direction only. So the system is suitable for the old towns having the unplanned roads and localities having uncontrolled growth. Okay, there are some merits and demerits of this system. The merits of this system are the system is simple, economical, and can be extended according to the growth. To control the flow, number of valves required are less. And the demerits of the system are for firefighting, sufficient water may not be available as only one pipe is supplying the water. And second demerit is due to many dead ends, water does not have free circulation, which may lead to the contamination of the water. Second type is called as a ring or circular system. The main pipes are laid around the area of the zone to be served. In the diagram you can see that depending upon the pattern of the roads, the closed ring may be of circular or the rectangular type. The discharge is divided into 2 parts, each going along the boundary enclosing the area in the zone and meet again at the other end. Cross pipes connecting 2 mains from submains. The system is suitable for the towns having the well planned roads crossing one another at right angles. The merits of these systems are the water reaches at particular point from 2 routes. So there are 2 routes for each point. The water is available from all the direction for extinguishing the fire. Then during the repairs, water supply can be made from other submains. The demerits of this system are the system is costly to construct and it requires more length of pipes and more number of sluice valves. Okay. The third system is the another type of distribution network or the layout is gridiron or interlaced system. So it is also known as reticulation system. In this system, mains, submains and branches are all interconnected. In well planned city, growth of the town is allowed to take place in the predetermined manner. So the roads are planned in a gridiron form. The pipelines laid under such roads naturally form the gridiron shape. This system is provided in the Chandigarh, which is in Punjab. The system is therefore recommended for the well planned towns or the cities. In the diagram you can see the roads are planned in the gridiron form and pipelines are laid under the such road naturally form the gridiron shape. Hence the name is given as a gridiron or interlaced system. And these types of systems are used for well planned cities. So it is already used in the Chandigarh. Now we'll see the merits and demerits of the system. So the merits of this system are since there are no dead ends, there is a free circulation of water. Head loss is minimum in the system. Then for firefighting, water is available from all the directions, and during the breakdowns, water supply can be made from other submains. The demerits of the system are the system requires more valves and longer pipes, making the system costly. So it requires more number of balls and longer pipes, so the cost of the system increases, and the calculation of the diameter of pipe and pressure at the point is not so easy. So these are the demerits of the grid or interlace system. Now last type of the system is the radial system. The system consists of laying the pipelines radially ending at the periphery of the area of the zone. So in the diagram you can see this system is consist of the pipelines and which are placed radially ending at the periphery of the area at the zone. In each zone, elevated service reservoir is placed at its center. So from where water is admitted to these radially laid pipe known as the branches. The water is pumped into these service reservoirs through the mains and water is withdrawn through the radially laid branches for the consumers during the supply. So the only thing is these pipelines are laid radially and there is a reservoir or a service reservoir is placed at the center of each zone. Okay. So and the water is then pumped through these reservoirs and supplied to the consumers. This is what the radial system is. Now we will see the merits and demerits of the radial system. Water, first merit of this system is water is supplied to the consumers at high pressure. How they can get it may get the high pressure, because there are number of reservoirs which are placed at the center of the each zone. So the pressure head will be maximum and water is supplied to the consumers with the high pressure. Second is designing of pipe size is very simple. There is a quick and efficient supply of the water. The demerit of this system is, as every zone requires a separate service reservoir, the number of reservoirs required are more and hence the system becomes costly. So this was about the different types of the network layouts which are used in the water distribution system. Now next we have to see is the how this water is distributed among the consumers, that we have seen, but this water is stored in a service reservoirs, and there are a number of types of service reservoirs which are used in the water distribution system, that we have to see in the next lecture. So the just I'll explain or give the introduction to the next topic, and we'll start the topic in the next lecture. In the next lecture we are going to see the information about the reservoirs and the types of reservoirs. Some reservoirs are placed at the surface, they are known as the surface reservoir. Some reservoirs are located in the elevated to the with respect to the ground level, and that type of reservoirs are called as elevated service reservoir, which is popularly known as the ESRs. So there are number of types of ESRs based on the materials used for the construction and based on their shape. So they may be of the RCC cylindrical tanks, or the steel tanks, or the conical tank, circular tank, or egg-shaped tank. We have seen many times the elevated service reservoir in the city also. So after this, what is the capacities of this distribution or the service reservoirs, that we have to see. There are basically three types of the capacities. We need to maintain the balancing storage, fire storage, and the breakdown storage. What is mean by balancing storage, fire storage, and breakdown storage, that we'll discuss in the next lecture. And there are some methods of calculation of the design of this reservoir's capacity, and the method is one method is the graphical method, and another method is the analytical method. That also we are going to see in the next lecture with the exercise of one numerical that we will solve in the next lecture. Okay. So I hope today's topic, you understood today's topic, and it will be easier for you to gain the knowledge about water distribution system and the layouts of the network. So in this particularly what we have to remember is the 4 layout systems or the networks of the system are dead end system that we have seen. Where these systems are used, that we have to remember, because it is very important that which type of system is used where. So there are 4 systems that we have seen: tree or dead end system, then ring and circular system, after that it was grid or interlace system, and finally it was a radial system. So which type of system is used where? If we consider the tree or dead end system, then it is used for the old towns. So in the MCQ exam they may ask this question, if we want to design a water supply scheme for an old city or the town, which type of layout of the distribution pipe network you will use? And there will be 4 options: tree or dead end system, then ring system, then grid iron system, and the radial system. The answer will be tree or dead end system, because for the old towns this system is popularly used. Similarly, there are the applications of ring or circular system. Then grid iron system is, we know that it is to be used or recommended for the well planned cities. And the radial system is used where, or what are the advantages and merits and demerits of this system that we have seen. Okay, so we will stop here, and in the next lecture we will continue this topic. Till then, take care. Bye. Thank you very much.